So the second one is using my truth table. So I will be having the truth table to represent my digital circuits. So using truth table, I can write a Verilog code. For writing this Verilog code using truth table, the model is called as behavioral model. So I don't know the Boolean expression of my digital circuit or the logic structure. Even then I can able to write a Verilog code using this behavioral modeling only with the help of truth table. The other hand is a structural modeling or gate level modeling, where I don't know the Boolean expression, or I don't know the truth table. I know only the logic structure. By using the logic structure of the given gate or any logic diagram, I can able to write a Verilog code, which is nothing but my structural modeling code. So these are the
Sorry,
three.
in that structural modeling,
Hmm.
you still need truth table, right? Like,
No, 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 no need.
oh,
No
like,
need.
then how will be the inputs on the outputs decided?
I'll
Like,
I'll I'll I'll,
okay,
I'll teach you. You
yeah,
need to write only how A is connected to B or B is connected to. So you need to make only how the connection is made. So even
okay,
then you can get the output.
okay,
So
sure,
that is your structural modeling.
okay,
So before going to any programming, you need to know two things. One is your operator and the second one is your operand. So with if you are strong with this operator and then the operand, you can easily write any code. So we'll see what is that operator and what is that operand one by one. Then we'll move on to the syntax of the program and then one by one. So as I already told, general purpose HDL, it is very easy to learn as well as use, and the syntax is similar to C programming, and it has a different level of abstractions to mixed in some of the models. So different level of abstraction is nothing but switch level modeling you can write, gate level modeling you can write, transistor level you can write, or behavioral code you can write. These are the three different methods which I already told. And one more feasibility here is you can mix your gate level with the data flow modeling. So gate level modeling or the structural modeling can be mixed with data flow modeling, but not with the behavioral modeling. So this mixing is also possible in Verilog. So and it is a case sensitive, and it has as I already told, the flip flops as well as logic gates are the leaf cells. So they are inbuilt libraries. So gate level and switch level primitives are already available in the libraries. If you type AND or this ampersand, it will perform AND operation in your Verilog. So this is a comparison between your VHDL and Verilog. So where it has started, how it is started. 1987 in US laboratory it has started, but in Verilog is 1985. So it is a older one than that of your VHDL. So this VHDL is IEEE 1076 standard. It is 1364. Similarly, some different functions are there. The level of complexity, if you see, VHDL is difficult, and here it is average and easy to read. No, PHDL is difficult, it is a lengthy one, and you need to know the entire structure, only then you can able to understand what is the programming flow. But here if you know a little bit, you can able to understand the flow of the program. Predefined features are very poor in VHDL, but in Verilog it is good. So tools are more or less the same. So clock models, it will work for asynchronous, multi-phase, multi-clocks. Both are same, asynchronous, multi-phase, and multi-clocks. So both are common for sequential as well as concurrent statements. And again, a finite state machine also we can write. So there is no semantic for this. Just a simple comparison between Verilog and the VHDL. So this is the syntax of a basic building block. Before writing a code, you need to know the syntax. So the first word will be module. The first word will be module. It should be in small letter, not a capital letter. Module is the keyword to identify that the program is in Verilog model. If it is entity, if you find it is entity, then it is a VHDL. So if it is module, then it is a Verilog code. So once you define a module, you need to give the name of the module. What is the module name? Then followed by its terminal list. Terminal list are nothing but my input and output variables are the operands. So when you are defining this module name, you should not start with numbers. Suppose if it is a 2 cross 1 mux, so you should not start your module name as like this 2 cross 1 mux. Always you have to start with alphabet mux 2 cross 1 or and 21, like this you have to give the name of the module. You should not start with number, always you have to start with alphabets. Then you have to declare the ports or the terminals over here. Then end the modules, module internals. Module internals are nothing but three difference of a programming model, whether it is a data flow or behavioral modeling or structural modeling. We will be writing all the module internals. Then by closing the program, we have to use this word end module without a semicolon and without space between end and module. So the module name is an identifier that is a user defined one, and the module terminals are nothing but my input output terminals. So this is a simple syntax. Let's go one by one, you will get to train what is. So this is the block diagram representation of a module. So first you will have a module followed by module name, then port list followed by port declaration. Port list, suppose you have an AND gate A, B, Y. Y is my output, A and B are my inputs. So here I need to define A, B are inputs and Y is my output as a port list. And here I have to declare which port is input, which port is output, and what is the size of A and B, whether it is a 1-bit value or 2-bit value or 3-bit value or 4-bit value. And if any parameters present, I need to define, that is an optional one. Next, if I go for structural modeling, say this is an flip-flop and this is another flip-flop. So if I connect my structure like this, I have to use wires. I have to use wires. Wires are nothing but general meaning intermediate connection. It is used for connecting between the blocks. So I have to define this particular line as a wire. So this wire also may be a 1-bit value, 2-bit value, 3-bit, 4-bit based on the my first and second blocks. So this is used in my structural logic, not in behavioral or not in data flow model. So next I have to find which modeling I am going to use. So as I already told, if you have a word called module, you can able to find it is a Verilog programming. In Verilog, you have three types. So how to identify those three types? By using a keyword. So if you follow a data flow statement, which is nothing but a Boolean expression. So you have to use a keyword called assign. You have to use a keyword called assign. So whenever you have a program with module followed by assign, which means it is a data flow modeling program. And if you find any always block or initial blocks in the program followed by a behavioral statements are nothing but your case statements. You will be using if statement, if else, while, for, all the nested if. All these statements will be using in only in behavioral modeling. So if you find always statement, then it is your behavioral modeling program. And if you find the lower level instantiation like port map, the word called port map, then it is your structural modeling. Or if you find the connection of your lower module, or if you are calling some subprograms in your main module, if you have some subprograms, then definitely it is your structural modeling. Then if you have any task and function, you have to define. Then finally the end module statement. So this is the flow of your program. Any doubt till this?
No, not now.
So the next one is your ports. So ports are nothing but my input output IO device, which I'll be giving the input and I will be getting the outputs. So which provides the interface to a module and which can communicate to its external environment. So there were three types of ports. One is your input and the other one is output and the third one is in out. So if you take input, it is an unidirectional port, only one direction from external world to the simulator or simulating environment, it will get the input, and the output is from the simulator, it will give the output to the external environment. But in out is nothing but a bidirectional port, so it is also called as wire. So as I already shown in the previous one, it is a wire. So this wire is the output of my first block and the input of my second block. So this is a wire. I can define my wire as wire also in out. Both are same as both are bidirectional. So I'll tell as a in out it is a bidirectional because the output of my first stage will be given as the input of next stage. So here it is output and here it is input. So in and out. So as both it is having, so it is defined as in out and also a bidirectional ports. So this is how you need to connect your or write a program for port connections. So this external environment is nothing but our users. So this outside arrow mark indicates the user. If you are defining a wire to the simulator, you have to write as a net. Similarly, if you are writing an input, you have to use a register or net, and the simulator will consider this as a net. So input and output are opposite to each other. So here it is register, and the simulator side or the inside of this environment, this will be treated as register or net. And inside the simulator it is net, and it will be transferred to our outside as a net. So inputs will be given in a register and output will be taken again from a wire. This is a port connection rules.
One second. Uh, while writing the Verilog code, when will we use a wire, and then when will we use the reg type?
Reg will be used in your behavioral modeling. So as because what
Okay.
is a register? What is a register?
Like where the for which the code we are writing, right? Like.
Yeah, one second. So I already told this, and net is used in your structural modeling, right? So you will be
Hmm.
having a structures like this,
Hmm.
and we'll be interconnecting them. It may be
Hmm.
connected here, or it may be connected here, or this may be connected, and you will
Hmm.
get the output. So
Hmm.
this will be my first wire, and this is my second wire, and this is my third
Hmm.
wire. So I can define this W's as net 1, net 2, net 3, or wire 1, 2, 3, 4. So when I go for structural modeling, I will be using this net.
Hmm.
When I go for behavioral modeling, behavior
Hmm.
means I need to cross check the behavior of the person based on his previous activities. So if you take an example of your friend, yesterday he was in good mood, you have cracked the same joke and he laughed, and today you are cracking the same joke but he is not laughing because he
Hmm.
is in some other state. So you have to cross check the behavior of the particular person by knowing his previous state. So in that case, you need to hold what happened now. The recent result is false. So that result has to be stored in a register for a while for cross-checking with the previous data, whether both are same or both are different. If both are same, no issue. If both are different, you have to cross-check. You have to ask your friend what happened to you, right? So when you go for behavioral checking of a circuit, we'll be using this register to hold the output or to store the output for a while for before when how much time it will be pre-checking with the predefined data. So that's the use of this register and net. Very clear?
Yeah.
So next is this basic concepts. What is a white space? So when you use backslash and forward slash this one, which will be nothing but a blank space, and for tab, and this is for new line, and we'll be usually having a commands, right? How to you will
Hmm.
be having a many line of programs. We'll be converting some of the lines, or we have to skip some of the lines, so we'll be using
Hmm.
comments. So if you use double slash, which is nothing but a single line of code, will be converted to a command, single line command. For
Hmm.
multiple line command, we have to use this syntax. So slash followed by a star and the line, how many lines we need to skip at the end of this line, you
Hmm.
have to specify like this. So 1, 2, 3, 4, 5. All these 5 lines now become command line or it will be skipped. So this is your multiple line command.
Yes.
So within multiple line command, you can have single line command also. So this is also possible in this one. And the next one is operator. So I already told you need to know operator and operands. So operands are nothing but your what you call operand
In input output. Yeah.
are the variables. So operators are nothing but the function which we are going to operate between the operand. So here there are three types. One is a unary operator, binary operator as well as ternary operator. So unary operator is nothing but one. Binary means two, ternary means a three. So this operator will perform only with single operand. So tilt of A, which is nothing but you are complementing a register A or complementing the variable A. Suppose A value is 0, after this instruction or after the programming of this line code, this will become 1. Only one operand you have to use. And the binary operator, it is between the operand A and B. So it is nothing but my AND operation. So between two operands, I will be having an operator, that is my binary operator. Ternary operator is for between three operators, between three operands. So take yes as a condition. I need to cross check. I need to ask the question whether the condition is true or false. 1 means true, 0 means false. So 1 means true, 0 means false. So if it is true, it will execute my true statement which is defined at this place. If not, it will define the false statement which is defined here. So this will be my true statement and this will be my false statement. So I will say like this: when s is equal to 0, the first condition will be defined. When s is equal to 1, the second inner condition will be executed. Or when you use a ternary operator, you have to start from left right to left, little Indian notation. So from this LSB to MSB, the execution will starts. So these are the three different types of operators. So next you need to know how to represent a number. We'll be having different numbers. You should know how to represent a number. So as it is a digital circuits, the inputs will be only zeros and ones. So you have to deal with only the zeros and ones. It may be a 2-bit value, 4-bit value, 8-bit value, or 16-bit value, or 32-bit value, or the power of 2. Power of 2, why power of 2 is, it is a base 2, binary. Binary means 0 and 1. So it will be power of n. N power 2 power 0, 2 power 1, like that. You will be having the size of the data. So when it comes to digital, you will be having different ways to represent. One is your binary and the other one is your decimal, octal and hexadecimal. These are the four ways you can represent your zeros and ones. So how to form the syntax for it? First one, your size. What is the size of this data? Suppose 01 means the size is 2. So 1010 means the size is 4 and this is the data. 1010 is a digital data and the size is 4 bit, and this is a digital data and the size is 2 bit. So you have to use this apostrophe to represent it is a size, followed by the base format. These are the base formats. So B means binary, O means octal, H means hexadecimal, D means decimal. Then followed by the number. So if I say it is a 4-bit number, this number should be here. So this is what the number representation in your Verilog. So D for decimal, H for hexadecimal, B for binary, O for octal. So here it is 4-bit binary 111. So 4-bit binary 1111, which is the meaning is it is a binary data of 4-bit. This is the data. 111 is the data. Similarly, it is a hexadecimal 12-bit value, 12-bit hexadecimal data. The data is ABC. So when it is ABC, what will be the size of A, B and C? It is a 12-bit data. So we are representing in hexadecimal format. What will be the size of ABC?
Like it will be like it since it's hexadecimal, it will be 16. Like,
Okay, 16 bit, but
hmm,
actually we are using only 12 bit. So it is
hmm,
a 12-bit data, which is nothing but ABC. So size of each will be 4 bit.
4-bit, yeah. Hmm.
A will be 4 bit, B will
Four.
be 4 bit, C will be 4 bit. So we'll get a 12 bit data. So similarly, it is a 16 bit decimal value. The value is 255, 0 to 255. That's the
55
maximum decimal value.
maximum value.
Yes. The other one is unsigned number. So when it is represented without any base format, it is nothing but an unsigned number. So when it is unsigned number, the default size is 32-bit. The default size it will take it as it is a 32-bit value, and the format also be a decimal. And other things are x and z values. X is nothing but unknown value. Z is nothing but my high impedance value. So unknown value is used to represent my output when you are simulating a program. So because only when I simulate the inputs, I will get to know what is my output. Until that, my output is unknown. Similarly, Z is my input. I will be representing my input variables as HIZ in my simulator. HIZ is nothing but high impedance state. So it is the transition between 0 and 1. So you will be having a clock pulse. So this is my Z. This is 0 and this is 1. So this is my Z. So at the beginning of the program or beginning of the simulation, I don't know the state of my input. It may be 0 or 1, but I don't know exactly. Well, based on the forcing, what I'm going to force, I'll get to know whether it is 1 or 0. Meanwhile, till I force the value, my input will be in terms of Z, HIZ, high impedance state. If port mismatch or I have not called my subprogram properly, then my swapping of these variables will happen in the simulator window. So I can able to cross check whether the connectivity is proper or not. When you go for structural modeling or any other modeling, in the simulator window, if I have a value A as my input, and it should be shown as HIZ. Instead of HIZ, if it is shown as X, which means A is my input, but the simulator is considering this A as output. So there is a mismatch in the connection, or there is a mistake in the code. The vice versa also possible. Y is my output and it should be as X, but the simulator is showing it as HIZ. So its output variable, it should be yes, X, but the simulator considering it as a HIZ. That is my input value. So this is also wrong.
So while declaring the unknown value, we should always use X.
No need to use simulator itself, it will take.
Self.
Only
Okay.
our aim is to write the module.
Hmm.
So I'll show you now how to write a code for AND gate and how to simulate it. We'll see.
Okay.
And this is for the base format for negative numbers. Yeah, it is an minus 6D3, a decimal value, which is of in 2's complement form. And two more symbols are there. One is underscore and another one is your question mark. So this underscore you can use in your module name. So as I already told, mux underscore 21 or 2 cross 1, like that you can use. And this underscore is also used in the program for the readability of the data. As because we are using only zeros and ones, so continuous zeros and ones, a file of 1 MB with only zeros and ones, we may not know what is that exact data. To find the better readability, we can use this underscore between the data. At this size, we can define whether it is between 4 bit or next all the 4 bits, or after 3 bits or after 5 bits. That based on our readability, we can use this underscore for reading purpose. And the question mark is alternative for Z. So here one more possibility is your UDP, user defined primitives. So as I already told, the truth table for an AND gate, you have 0 0, 0 1, 1 0, 1 1. These four combinations are already available in the library function. By typing a keyword AND, I can able to get the output of this AND gate. I don't want this truth table. I want to have some more examples. I mean, some more combinations at the input style. So instead of 4 combinations, I want to write 8 combinations or 6 combination of the inputs. Is also possible with the help of UDP. In that case, the EZ comes into picture. I can take one of the input as EZ and the other input as 0. And likewise, both the inputs are 0, EZ. Then what will be the output? Like this, I can write a code using this UDP, user defined primitives. So in that condition, we'll be using this EZ. So an example, 4-bit binary 10 question mark. So unknown values. Similarly, instead of this question mark, you can use it as EZ. Both are same meaning. So if you write anything between say double quote, then this will be treated as a string, and a normal identifier as well as keywords. Keywords are your library functions. Identifiers are nothing but our user defined.
Uh, can you go back, like on that said thing? Yes. So here in the example, we are trying to find the last two value 4-bit 10ZZ. We are
Yes,
still trying to find the last two,
yes,
like since
yes,
it's
yes,
4-bit.
yes.
Okay.
Now let's write a program for an AND gate. Before that, I will go with the operators. So these are the different types of operators. We have a arithmetic operator, logical operator, relational operator, equality, bitwise, reduction, and more operators are there. So this arithmetic operator, multiplication and division, addition, subtraction, modulus, and here it is logical. This is logical negation and operation. This is for or operation greater than less than or equal to. This is equality. This is arithmetic case. This is a logic condition. This bitwise operation and the reduction operation more or less same, and shift operation, concatenation operation like this. This is my concatenation, and this is my replication, and this is my conditional operation. So in Verilog, we have to use only the symbols to write the program. We should not use any words. So we'll be using only the symbols. So this is an AND gate program. The output of y is equal to a and b, or the Boolean expression will be a and b. So first I need to start with module followed by module name. So I'll say it is AND 21. Then I need to define my port list. So it is better to use the order. First you have to define all the or call your all the output variables followed by your input variables. So here my output variable is y. I'll call my output variable y first. First my output variable followed by my input variables a and b. Next, I have to declare which are all my inputs and which are all my outputs. So again, I will go with my output first. Output y, then input variables a, input b. So this is also possible, and you can write like this also. Input a comma b. When they are of same size, you can use this statement or this one. Individual also you can define, or in a single line also you can define. So next is your which modeling you are going to use. First we will go with this data flow modeling. So data flow modeling is nothing but with respect to your Boolean expression. So Boolean expression is identified with the help of assign as a keyword. So it is my AND gate. So I'll be using a keyword assign for my output y is equal to a and b. As I told, you have to use only symbols in the program. Assign y is equal to a and b, then followed by end module. So this is a 2x1 AND gate program using data flow model. A simple one line code. That's all.
Yes.
So let's see how this code is simulated. So have you used this Xylene simulator or ModelSim simulators?
No, I actually in college we used like Synopsys VCS tool, but
Okay,
I don't have idea about this one.
okay, fine. So it's nothing but your backend tool. You can do
Mm-hmm.
both physical as well as logic simulation here. So I
Okay.
have integrated both ModelSim as well as Xilinx.
Okay.
So when I open this Xilinx, it will looks like this.
It's a open source, I like free.
Yeah,
Uh,
yeah, open source. I will share.
okay.
So these are all my previous projects which I have done. Now let me close that and I'll open a new project. So you can first you have to browse your location. Can you able to see this window?
Yeah, I can.
First you have to browse your location, then give the project name. Let me give it as and21. This will be the project name, not the module name. And I
Okay.
will take it as a top level module as HDL. It may be schematic, EDF and NGO. I'll take this as HDF and click next. These are the some of the FPGAs which we are going to dump our program and check the output. But
Hmm.
here we'll be using only the software part. So I'll take this Spartan 3E with a device family of 100E, package of VQ100 and the speed grid as -4. The top level simulation is HDL and the synthesis tool is XST. Simulator is ModelSim. Generated simulating language is VHDL or Verilog. We will be using Verilog. Then click
Hmm.
next, next, next to finish. So now you can see here the sources in the project. Your project is created and 21.isc. Wherever you find a
Hmm.
file with the .isc extension, which is nothing but a Verilog file, Verilog
Fine.
project.
Hmm.
Project.
Hmm.
So in this project, I have added my Spartan 3 device, so
Hmm.
which is shown here, the blue color highlighted one. I used to
Hmm.
tell this is a project or the device.
Hmm.
And see here, the process for source, nothing is here. One is design utility is there, create new source, add existing source. Only this
Hmm.
terminal is here now. So
Hmm.
now I have to write a code using this simulator. So first right click on this new source. It will open this window. Here we have to select Verilog module, right? If you have VHDL, you can take VHDL. If it
Hmm.
is a test bench, you can test bench a Verilog test picture.
Hmm.
Similarly, VHDL test bench like that you can go for.
Hmm.
So we are using Verilog module. Select this Verilog module and give the file name. This is the name of the module. Here you should not
Hmm.
start with number. So I'll take this as and underscore 21
Okay.
and you make sure this is added to the project. So if you want, you can declare your variables over here, whether it is A and the direction is input,
Input.
output or input, like that. And what is the size of it? If it is a 1-bit value, no need to specify MSB, LSB. So if it is a
Hmm.
6-bit value, you have to define LSB as 0 and MSB as 6. Or the other way is also possible. For
Hmm.
all the variables, you have to use the same notation. Whether if MSB is 0 means LSB is maximum, you have to follow the same. Whether it is a big Indian or little Indian, you have to keep the common
Hmm.
formatting for all the variables when you define the size of the variable. So sometimes it will confuse us when you go for a complex design. So
Hmm.
we leave here and this is our source type Verilog module, source name and21 and the module name is and21. So on the right hand side, you can see your editor window is open. This time scale 1 nanosecond for picosecond. The timing it required or then the waveform you can refer only with
Hmm.
respect to nanosecond or picosecond. So this is a
Okay.
time where it is created, what is the module name, and all these things will be shown here. And
Hmm.
this is the default syntax. Will be
Hmm.
comes like this: module name, followed
Hmm.
by this semicolon and end module. The
Hmm.
remaining things we need to type. So below the device, you can see the sources and port. My
Hmm.
Verilog file is being generated and underscore
Hmm.
21 dot
Hmm.
v. So dot
Hmm.
v means
That
it is
way is
a
very
Verilog
low.
file
Hmm.
and dot vhd means it is a VHDL file. So now I need to define my variables. It is an AND gate 2 cross 1. So
Hmm.
first I told you how to take your output variable. So y first, then a and b. So you can use any variable,
Hmm.
but you should not use the same variable for both for input as well as output. So and output is y semicolon input a comma b. Now I have defined and declared my variables. It is a data flow modeling. I have to use the command
Hmm.
called assign. y is equal to a and b.
Hmm.
So that's all about an AND gate program. Just click save. So you can see in the process view here
Hmm.
the compile
Hmm.
Verilog file and 21.v. So
Hmm.
here I have only one file, so it will compile only the particular file.
Hmm.
Suppose here in the previous project I had some 20 files. If I
Hmm.
click save, the recent file what I have worked
Hmm.
will be executing. So I may thinking that I need to run or compile an undegate file, but if I click save and run, it may run in a some other program. So you have to make sure that which program we are going to compile, that has to be selected, and then it should be. Now you can see the different tabs are added in the process. See, generate programming file, implement design, synthesis XST, user constraints, design utilities. All these tabs are added. So this is my process. So I expand this synthesis XST. I need to check the syntax of the program. So double click on this check syntax.
Hmm.
So it's running. So when it is a green color tick mark, the
Hmm.
program is succeeded without any syntax error.
Hmm.
Now, if you want to see what is the RTL schematic, the code what it can double click on this view RTL schematic. A block
Oh.
diagram, a top
Hmm.
level symbol will look like this. Again, double click on it. This is the structure for which you have written your code. So
Oh.
out of this URLs, if you double click on it, again it will go back to the
Go back.
main module.
Hmm.
You can close this. Then double click on this view synthesis report. So in the synthesis report, you will get to know all of these things. The first one is your synthesis option summary, HDL
Hmm.
compilation, HDL analysis, HDL synthesis, and the synthesis report, level synthesis, and memory utilization and timing report. So
Hmm.
all the details you can study with the help of this view synthesis. So mostly we'll be checking this final report. So top level model use and 21 and the number of IOs are 3. So 2 input and 1 output
Hmm.
and cell usage. LUT we have used only 1. IO buffers we used 3. 2 is input buffer and 1 is my output buffer. So it is being shown here. And the device utilization summary. I am using this Spartan 3 kit. This
Hmm.
is having 960 slices, 960 ICs, out of which I am using only one. And then yeah, it is having a 4-bit LUT. The
LUT
number
is
of
a cell, right? Type of cell. Is it?
and no, LUT is nothing but a truth table. So the
Oh,
predefined values will be already available there. It's
okay.
like an image. You can cross check. Instead of writing the program, you can directly call the LUT and you can minimize the limit.
Oh, oh, okay.
So out of 1920, I'm using only one. The utilization is 0%. Again, it is 0%. And
Hmm.
IOBs, I have 66, out of which I'm using 3, so 4%. So out of in this Spartan 3, I'm using only 4% of the hardware. And how much time it takes to produce my output is this is the
Hmm.
timing analysis. So within 9.4 nanoseconds, I am able to get the output of an AND gate by using my
Hmm.
Verilog code. So by forcing my in IOs, it takes 1.93 and the
Hmm.
net delay. This net delay is for my transmitting from input to output, the wire delay. So
Hmm.
this is for input buffer and output buffer. It takes only zero point 0.7 and this is zero point 0.08
Hmm.
and output buffer it takes 4.87 nanoseconds. So overall, if you calculate, you will get a 9.45 nanoseconds. So out of which 7.5 nanosecond is for logic, that is the input transfer between the input or the time taken to transfer between
Hmm.
input to output or the
Output.
propagation delay, and
Hmm.
1.84 nanosecond is for routing for the wire delay. This one
Hmm.
is two delay of the wire, and if you add
Hmm.
this 3 it will be the buffer time or the input combinations whatever we are forcing, so that takes 7 point. So 80 percentage is for logic and this 19.6 percentage is for routing. So all these reports we can take using the synthesis report. And if you have any some other programming style like a behavioral modeling or structural modeling, So you
Hmm.
can cross check the synthesis report and you can write as analysis which one is providing better output with less number of devices and all you can check.
Okay. We can compare both of them.
Yeah, you can compare. Or you can compare the same Verilog program data flow modeling by
Hmm.
changing the device. So here I have used Spartan 3. You
Hmm.
can take some other device also. So
Okay.
in Vertex, some other device, just
Hmm.
write the same code and download it and check how much percentage it utilizes and what is the device utilization, what is the time required to complete the output and all you can analyze.
Hmm.
So next my syntax is over. Now I need to simulate it. So I can use this user constraints. This is for downloading my this program a bit file into an FPGA, that is nothing by Spartan 3. When you connect it through via
Hmm.
JTAG cable, you
Hmm.
can download it. That is for physical design. Now we are going only for the logical design. So
Hmm.
we use this design utility. As I already integrated my model sim with this Xilinx simulator.
Hmm.
So double click on this launch model sim simulator. So you will be having some different windows. So there are four windows. One is your workspace, and the other one is object, and the wave default, and the
Hmm.
fourth one is your transcript.
Hmm.
So this workspace is the path where your design is available and what is the unit and what is the visibility and all. So it is also called as instance. Instance is nothing but the module and the variables which are all available in this particular module will be called as object by this model sim simulator. So the objects are nothing but A, B, Y. These are all my variables. So
Hmm.
these variables to be transferred to a wave window to cross
Hmm.
check whether I'm able to get the result or not. So here comes this kind of definition. So inputs are to be defined with net. So we have seen that port connection rules, right?
Yes.
So in either register or net. When I go for behavioral modeling, it is a register. For other models, it is net. So A, B, and as well as X, my Y is my output. So again, it is the output side. So it will be again a net. So already told inputs are A and B. So it should be with HIZ, high impedance state. And output is my X value, STX, unknown value. So if anything is different in this, so I have defined A as a input, but if I see here as STX in place of HIZ, which means I have misconnect. The connections are misplaced. The variables are wrongly defined or declared. So it is not the program is wrong. We have to rewrite it. Before executing, you can able to check whether the variables are declared properly or not. So here the variables are declared properly. Now I am going to simulate and see the output waveform by maximizing the wave window by using this pop in pop out symbol. So we have already seen in the program the output will be either in the nanosecond or in the picoseconds. If you see the scale, it is of in picoseconds from 200 picosecond, 400 picoseconds. So initially there is no data for A, B and Y. But if you see in the object window, it is HIZ, HIZ, HIZ. So here it shows no data at the initial stage. Now I need to force my input values A and B. Let me select A, right click. So I'll go with force. Click on this force. So no need to change anything in the signal name. You can cross check which variable you are going to assign. So it is a variable A and it is HIZ. So it is nothing but my input value. And you need to specify what is the size of this A. So what will be the size of A here?
It will be 1 bit because we haven't defined
Yes.
anything in
So
our.
we need not to bother about it. The
Hmm.
number of widget at this place is the size. So
Size.
here it is only one widget.
Hmm.
So it is a 1 bit value. So as
Hmm.
it is AND gate, first combination is 0 0. So let me give 0 for A and no need to change anything in this kind or delay and all. Then
Hmm.
click OK. Then similarly select B and force again first
One.
combination it is 0. Click OK. Now need not to force the value for my output value, output
Hmm.
variable. Now click on this 100 picosecond. Next to it, we have a down arrow called run.
Hmm. Hmm.
Click
Hmm.
on this run one times or two times.
So
So
it
you will get a
A and B value will start from zero, right?
yes.
Hmm.
So because 0 0 is the first set of input combination for an AND gate.
Hmm.
So I am giving my inputs as a 0 0 and my output is also 0.
Zero.
So by moving this yellow color cursor, I can able to check what is the output. So now I need to go for the next set of input combination. A will be 0 and B will be 1. So let me change it to 1. So even deleting STX as completely 1 or this is also possible, no issue. So now it is, I have forced 0 1, but you see here the data is not changed for the A and B as
Hmm.
because my cursor
Hmm.
is not moved. So I move my cursor 0
Hmm.
1, again the output should be 0. The other condition is, so if you want to select multiple variables, press Control
Hmm.
and select all the variables, then
Hmm.
force. Now it will be 1 0 and run again.
Hmm. So it comes
For
to
1
one.
0 also
Hmm.
it will be 0. And
Hmm.
the last combination is
Hmm.
1 1. So
Hmm.
1 1 it is an AND gate, output is 1. So now if you want to file this one, you can take this export image and
Hmm.
or save format as anything you can take or using snipping tool you can snip it and in the
Snippet.
paint invert color whatever you want you
Hmm.
can save it for your reference. So again
Okay.
pop it up to like this. So this is how you can write a Verilog code for an AND gate. Similarly, if I change the symbol to OR gate,
Or
so
get.
OR gate is a straight line, so which is nothing but in the keyboard above the enter key you will be having a straight line. So shift and forward slash you will get this R symbol. Now it will become OR gate.
Hmm.
So once I changed anything, even a small change in the program, I need
Hmm.
to start from the beginning. Again, I need to start from the beginning. So as I change the R gate, if I go to the wave window and change the values, I will not get the output of R gate. I will get the output of my previous program, that is
Previous.
AND gate. So instead of going like this, you can double click on this synthesis XST. So you will get everything checked
Hmm.
and then you can go for launch ModelSim simulator. When you go
Hmm.
for the next program, it is better to close the ModelSim which you have already running.
Hmm.
So for our easy understanding that this program is there. Otherwise, you will be having plenty of ModelSims. You don't know
Hmm.
which output is for which program.
Which one?
So close everything and open new ModelSim and you can force and check the output. So
Hmm.
here it is. Let me go with the 0 1 combination.
Hmm.
So it is an OR gate. If one of the input is 1, my output should be 1. So the output is 1. So if I use cap,
Hmm.
then it is nothing but my XOR gate.
XR.
XOR gate. If I use a tilt in front of it, so tilt of cap, it is XNOR.
XNOR. Hmm.
Tilt of XNOR.
Hmm.
Then if I use AND, so this will become NAND.
And.
Not of AND, so it will become NAND. Similarly, if I use not of OR, then it will become NOR.
Hmm.
And if it is Y is equal to not of A, then it is
Hmm. Not. Nor
complement of
get.
A or an inverter, simply an
Hmm.
inverter.
Inverter.
Either you can use this exclamatory symbol or this tilt, both are gives you inverted
Hmm.
operation. So this is as I told you, a double slash will be a single line of command. So
Hmm.
see here, this will become a green color, then it is a single line. For the multiple line command, this is a multiple line command. This is a multiple line command. So within this multiple line command, I have a single line of command. So this is also possible. So for your better understanding, when you are writing a program, if it
Hmm.
is a keyword, it should be in blue color. If it is an identifier, it should be in black color. Suppose if you are
Yeah.
writing an out, if it
Hmm.
is yeah, there is a spelling mistake,
Hmm.
then it will become blue, black
Hmm.
color. And when you
Hmm.
are running, it will tell us output variable y is not declared properly. So because of the spelling mistake, also it will throw an error. Sometimes you will get an it will show error as at line number 24, but
Hmm.
actually the error will be in line number 23. So you have to check the first line and the previous line and the next line when you
Hmm.
get an error. Need not to
Hmm.
check the particular line now. So this is an off adder.
Hmm.
Have you seen this off adder circuit?
Yeah, but actually, it's been a little time. So, can you like explain the circuit as well?
Off adder,
Like,
I'll explain. Off adder is nothing but it's an adder.
hmm.
Off means it is having a two input, two output. So input will be two and output will be two. So A
Hmm.
and B will be our inputs. Sum and carry will be the output. So the sum expression is A X or B, and the carry expression will be A and B, A dot B. So A dot B means it is an AND gate. So you will be having an AND gate. A
Hmm.
XOR B or A cap of B as we will be using in the program. So it is an XOR gate. So what is the input? Inputs are A and B. So
B.
inputs of the XOR gate is A and B. Similarly, A dot B. These are the inputs of my AND gate, A and B.
Hmm.
So if I this is a common for both this gate G1, I will say it is an XOR gate,
Hmm.
and gate 2 is AND gate. So
Okay.
A and B is common for both the gates. So I can connect like this. Common connections I can able to
Hmm.
make. And the output of XOR will be my sum. Output of this AND gate will be my carry. So why
Carry.
it is a sum and carry? As it is an adder, obviously you will be having
Some.
um,
Huh.
sum and
Wait.
carry. As
Hmm.
because we are using with zeros and ones, binary
Hmm.
values, there is a possibility of getting zero. This will be zero and this one. So this will be the sum and this will be the carry for this
Sorry.
data.
Hmm.
So here I need to write, I know the Boolean expression now. I know the Boolean expression for my sum
Hmm.
as well as carry. I need to write a code.
Hmm.
So when you go for this, this is your main module. This will be your main module.
Hmm.
The two gates to be inside this. So
Hmm.
main module will have two inputs and two outputs. That is the main.
Hmm.
So when you are defining module half adder, it is a data flow modeling. There should be only four variables at this port list: sum,
Hmm.
carry, A and B. Already told, first output variable, then the input variables.
Hmm.
So sum and carry are my output, A, B are my inputs. So again input and output. At this order you can interchange, no issue.
Hmm.
So there won't be any problem with this. Then again it is a data flow modeling. The keyword is assign. So assign sum is equal to A XOR B, and
Hmm.
assign carry is equal to A and B. And here also you can swap. First you can define carry, and the second you can define your sum. No issue. Then end model.
Hmm.
So you will get an output of this half adder. So again it is a 2-bit value. You will have 0, 0, 0, 1, 1, 0, 1, 1.
Hmm.
So what will be the sum for this condition when it is 0, 0?
It will be for some for XOR it will be
Yeah.
uh
When you will get output 1 when you go for XOR gate,
so when all the outputs are low, I
0,
think.
1, 1, 0, 1, 1. When one of the output input is high, you will
Hi.
be having 1. For the
Okay.
remaining conditions, it will be 0. This is for XOR gate. So
Hmm.
when it is 0, 0, XOR output will be 0. When it is 0,
Hmm.
1, one of the input is high, so output will be high. Here it will be
Zero.
high, and here it will be 0.
Zero.
Similarly,
One of the
carry,
output should be high.
yes, to get the
Okay.
XOR gate
Hmm.
output as 1. So for carry, it is a multiplication, normal AND operation, 0 into 0, 0, or 0
Zero.
into 1, 0, 1 into 0, 0. So the same way, you can write a program and you can simulate it in the simulator, and you can cross check the output, right?
Uh, yeah.
Okay. Shall I want to simulate it, or
Uh, yeah, we can check
yeah?
simulating it.
So now, when you go for the next program, you need not to create again a new project. You keep all
Hmm.
your modules in a single project. And
Hmm.
sometimes when you go for a multiplexer or decoder, encoder, you have to
Hmm.
call your AND gate programs as a submodules. So in that case, you don't know in which name you defined this module, right? So you have to call only this module name. You don't know what is the name of it. So to get to the name, better to keep all our programs in a single file. So for my next program, I'll select as again a new source, Verilog module. So it is a half adder using data flow modeling. So again, it is a Verilog module, half adder using data flow modeling, and click next, next, finish. So I'll get this. The hierarchy is been added here below the same device.
Hmm.
So half adder, I will have my sum, comma, carry, comma, A, comma, B. There were four variables. So inputs are nothing but A, comma, B. Similarly, output is sum, comma, carry or C, comma, S. That is also possible. No issues. Then two assign statement. Assign S is equal to A cap of B,
Hmm.
and assign carry is equal to A and B. So that's all. Let's save. So now see here, this gray color is highlighting this half adder, which means, as I already told, the recent program. If you click save, the recent program will be executed. You can
Hmm.
see here compile HE underscore D. But if
Hmm.
you want to, you might be thinking that you have a AND gate program here,
Hmm.
and you are thinking AND gate has to be
Hmm.
simulated or checked syntax, but it is selected half adder. Then if you say only half adder will execute, not the AND gate.
The
So
and
you are, yeah, you have to select the particular program which you need to. So no error. Let me close this. So again, A, B are my inputs, C and S are my outputs. So they are STX and they are my inputs, HIZ. So first I'll force 0, 0. My phone
hmm.
away. Phone away. Phone papa. So both are 0, 0.
Hmm.
So as both are 0, 0. The next is 0, 1.
It will be one.
For 0, 1, the sum will be 0, carry will be, sum will be 1, right?
Hmm.
Yeah, sum is 1 and carry is
And
0
carry is zero.
because one of the input is high. So the
Hmm.
other combination also will be same. And for 1, 1, it is sum will be 0 and and both are 1, 1. So sum will be 0 and carry will be 1. So
Hmm.
same inputs will produce output 0 for XOR gate, and for
Hmm.
carry AND gate value. So 1 into 1 it will be 1. So this is for half adder.